Hi, everyone. I'm going to try explaining and bringing you some alternative way to think about artificial intelligence. You know, when we speak about artificial intelligence, and you will hear about that for the next 3 days, there's kind of equivalent words. Machine learning, deep learning, big data, and artificial intelligence. For a lot of people, it's the very same. As if there was some 1 ounce of intelligence into the AI. Into this AI we are speaking about, there is no intelligence at all. It's just data treatment. It's just statistics. It's just with powerful tools, but it's that. And I think there are possibilities to make intelligence without big data. And well, in order to have you joining me on this trip, first, I will just try remembering you that I'm not totally crazy and totally fool. So I did the same kind of thing previously with robotics. I had a very different approach of robots. You know, for me, when you have a robot with someone, the star is the people, not the robot. And the robot has to be here to help the people, but has to be designed in order to. So it's a different approach of robotics than everyone else. And by the way, when I created this company, I was not a roboticist. I was not from the field. And I hired people that were not from this field. I hired even carpenters, biologists, to help me designing the robot. It was a totally different approach. And when I came and asked to different research labs all around Europe when I created the company, what they thought about my idea, they all told me, this is stupid, you never will succeed. It's not possible. And by the way, you are not from the field, so who are you thinking that you will be able to succeed where we tried that for 15 years without succeeding, more or less. So, and we did it, and because we were not prisoner, our mind was not structured with the main idea, with the know-how, with the habits, best practices, and whatever you want. So we did differently, and we did something, we turned world leader. I'm just saying that because I'm trying to do the same now with artificial intelligence. So let's begin our trip with my powerful friend. So if you ask ants to build a house, well, you can give them tools, but they don't know what to do with that. Ants are, let's say, individually very stupid bugs. That means they have less neurons than transistors in your toaster. So it's really very one by one stupid animals. But together, all together, wow, this is what they are able to do and to create. And this is the power of emerging system, multi-agent system. Pick some very elementary agents, give them rules, very few, 10, 15, 20 rules, and then put hundreds of thousands of them and see what will result out of that. And well, of course, nothing will result at the beginning, but after hundreds of millions of years of evolution, you will get something interesting. So for me, this is the amazing power of emerging system. So more than ants, I will go to another animal, which is, in my view, much more interesting. Termites. You know, termites, cousin of ants, 3, 4, 5 millimeters tall, and they are able to create termite mounds up to 10 meters tall. Look down the left, a termite colony the size of Great Britain. A lot of termite mounds together connected from the same origin 2,000 years ago. So this is done by small bugs, let's say stupid, each of them, with no intelligence. And look, if you go inside, and this is important, if you go inside, you will see that its temperature is controlled. Speed of the air is controlled. Humidity is controlled. And when I'm saying controlled, they may have up to 12 degrees difference between inside and outside. It's 40 degrees outside, 28 inside. No energy, nothing, just passive structures. And it's not all over the same humidity or temperature. You have rooms for fungus gardens, they're calling that, where they're picking a sheet of trees and putting them here and putting fungus on top of that to grow them because it's what they are eating. Right? So here they need to have higher temperature, higher humidity. So it's not all over the termite mound, the same temperature, same conditions. Wow. It looks like there is an architect. There is an engineer thinking here. But there is no architect, no engineer, nothing. It's just emerging system from basic rules given to a lot of agents, let's say. All the very same rules. Very important. I think amazing how nature is doing this kind of thing. You know, there is no project leader saying to a bunch of termites, okay, let's go and build this pillar, you will do this room. Nothing. You just have hundreds of thousands of small animals alone with interaction with the others, but having their own rules, deciding by themselves what they will do. Well, they're able to do 20 different things, let's say. Okay, I will do one of my 20 behavior. I will pick one, I will do that. Why? Because the condition, because I see. And the result is this system. It looks like if there was architect or engineer. In my view, we have the very same when we go for intelligence. I will go toward that. So multi-agent systems, very simple rule. Rules are hardwired. In the animals, it's important hardwired. In animals, of course, it's DNA. We can have that done with electronics or whatever you want. But the result is very, very efficient and very frugal. Okay, so now let's jump and try seeing the comparison with that with the brain. So let's look at the physical organization of the brain. You have, of course, the hemisphere and the cortex, plus a lot of other things. But you know, altogether, we have something like 86 billion neurons, not more, but 86 billion. And you have only 19% in the hemisphere, which is the cognitive part of the brain. The huge majority is beyond that is for caring about commodities of the body or immunology or whatever you want. Only 19%, 16 billion neurons are in the cortex for the cognitive function. And the cortex actually is a sheet, it's a 2D sheet wrapped up to fit inside your head, but it's just a 2D sheet, 60 centimeter by 60 centimeter. And if you look at that with electronic microscope, of course you will see a lot of neurons connected, so you can say it's a neural network, yes. But if you look closely, you will see that there are elementary structure, what we are calling a microcolon in the middle. This microcolon is 110 neurons connected together a certain way. And this is repeated with the very same way 140 million times all over the cortex. Well, actually, there is an intermediary structure. You have a bunch of 1,000 together, creating a cortical column. So the cortical column is the elementary function of the cognitive part of the brain. If you look inside, you will discover a lot of function into this connection, this cortex, but mainly you will see three kinds of analyses. Dynamic analysis of signal entering into this microcolon or this column, structural analysis and global analysis. And this analysis is the very same all over the cortex. That means with the same thing, with the same function, if they are right-tuned, if they are the right one, with the very same function, the cortex is doing perception, vision, audition, whatever, action, cognition, all the functions of the cortex, with the very same functions. Of course, down you have the neuron. So now, if we try going to the alternative way, mirror part, which is the functional organization of the brain, you have this microcolon that are the basic tool of the cortex. Then you have the colon, cortical colon, basic function, which are the agent of my previous system. The agent of my system are not termites or ants. They are these cortical colons. All the very same, doing the very same thing, but with rules fine-tuned by evolution. You put that all together, and you got all the function of the brain. Of course, you can see on top of that higher part, the different areas into the brain doing face analysis, doing word recognition, doing action, and so on. So it has been mapped, so we know more or less what each area is doing. But the basic of that, they are all having the same basic structure. Not important to read that. Important thing here is just to say, all of that is supported by scientific publication, Nobel Prize or whatever. So that means it's not crazy idea I have from nowhere. It's just gathering correctly what is existing. Okay, so now my deep conviction is that the cortex is nothing but a multi-agent system based on cortical columns. Simple rules, hardwired. So here, evolution has hardwired that into this connection of the different neurons, these small neural networks that we have. Very efficient and very frugal. You know, if you want to compare brain with the computers, if you take the Human Brain Project, the European project, millions of kilowatts to make something which is not working really, where the human brain is 20 watts. For all the functions, for the 100%, not for the 19%, or even less for the cognition part. So very, very, very frugal. It's important because when you speak about deep learning or machine learning, one of the key advantages everyone is putting is that this system are able to define by themselves the different axes of analysis of the signal from outside. So these axes of analysis are emerging from the deep learning. And they are very proud of that. For me, it's totally the wrong approach. Nature has chosen the best way to make the analysis of, let's say, continuous flows, data evolving in a continuous way. Nature has made the more efficient way to find that. What nature is able to do is to optimize things. Very well, very good. So it optimizes, and then it hardwired that. So it's closer to what people are calling capsule networks. Okay, so this is how the brain is working in my view. And if you are able to replicate this small part, elementary part of the cortex, then you can put together a lot. And the larger you will have, the higher in the abstraction layer of analysis your cortex will be able to go. The larger surface of the cortex, the higher you are able to go in terms of abstraction analysis. So if you look at animals, well, the main difference between human and animals is in the surface of the cortex, by the way. There are a lot of animals having a cortex. There are a lot having no cortex, but there are a lot having a cortex. But the question is a question of surface. And if you go from, I don't know, all the different mammals to the monkeys, then you have a higher surface of the cortex. From the monkeys to the bonobos, you have a higher. From the bonobos to the human, you have a higher surface of the cortex. So for me, this is the key element. One slide about my company, AnotherBrain. It's what we are doing. And the important thing is we are going for a chip that will replicate the elementary part of my view of how the cortex is working. But you can see down, so we already got results. We already have analysis. We already have customers. We already have analysis in plants, in real life, in complex life that deep learning is not able to do. All these guys didn't trust us, of course, at the beginning. So they compared. And as a result, they made a contract with us. So that means we already have things. We already have results. So the view I'm presenting, I think, is very prospective approach. And we are quite there. So now I will try to enhance a little bit. What can we have if we have a cortex surface, a higher one, chips replicating elementary structure of the cortex and then joining and joining and joining? Of course, you will have a cortex able to go to higher abstraction levels. This will bring us to theories. This will bring us to a lot of different things. And this picture drawing is interesting. The scientific approach is based, of course, on experimentation, is based on observation, but just after you have intuition. That means, okay, I see something, I saw something, I'm able to replicate or reproduce, great, but now how can I try having a theory? Then you got some intuition about what you have seen and how to do that, and you create a theory, and then you try making predictions with your theory, and then experimentation, and then you make observation. And if it's okay, you have the theory. If not, you have to improve. But you are beginning with experience, and then you need to have this intuition. And there are limitations in the intuition, because what is intuition? Intuition is nothing but a shortcut through all your experiences, all what you live in your life. So intuition is only that. But you only can have intuition on things that you have been able to live and to experience. And for instance, here I'm speaking about the chord theory, about cosmology, about these large theories that are very complex because they are projecting you into an 11-dimensional space. Wow, we are not able to have any intuition about that. So very difficult to live and to make theories. And by the way, we have a theory, a string theory, great, that gives the possibility, opens the possibility to space travel, opens the possibility to time travel. Well, it's one of the consequences if some parameters were fine-tuned correctly, if, there are a lot of if. But we are not able to check whether it's true or not, because it's very difficult to fine-tune our theories because we don't have the intuition about that. With this kind of system, we will be able to make the system live into a virtual 11-dimensional world, and then got some abstraction around what its own experience will make him having, and then helping having theories. So in my view, yes, AI will help us traveling into space. And it's something I'm interested in, so that's why, one of the reasons. Okay, so that's all. I just wanted to open you about a new possibility of doing AI, totally different that everyone is doing, out of the box. We are not computer science engineer, traditional one. We are not traditional, and that's why we are allowed to think differently out of this box and to bring something which already is demonstrated. Thank you.